All right, welcome. So today we'll be discussing transforming behavior analysis with AI, and along with me and Miguel Woods, who should be joining any second, is Planet's principal data architector, and he will be representing Planet and how the work was performed here at Planet. And then CyberQ is one of our customers, and from CyberQ, we're really excited to have Phil Houston, Simon Frechette, and Susan Carnicero joining us on the program today. We have a full agenda today, so let's go ahead and get started. As always, before we get started, I'd love to do just some quick anonymous polls to see where you're at in your AI journey. We'll review these results during the question period towards the end of the program. So when you can, please submit your answers to the polls. So, we're just kind of curious, are you still investigating it? Or you have nothing in Azure, utilizing AI in Azure? Again, these are all anonymous, so please don't be shy. Our agenda today consists of customer overview. We're going to be talking about with CyberQ and talk about how they implemented a very unique solution in Azure AI. We'll talk about CyberQ's objectives and how they utilized Azure OpenAI to develop and refine their solution. Then we'll explore the technologies and tools employed in the project briefly. And then finally, Simon's going to give us a really cool live demonstration of this AI-powered system called Q, highlighting its real-world applications and success. And of course, we're going to save some time for feedback at the end and questions. We had one question that came in advance. So, Phil, Simon, and Susan, go ahead and unmute. And if you could just go ahead and introduce yourselves and tell us a little bit about yourselves and your background. I think, Simon, you were going to go first.
Sure. Thanks a lot, Ken. Appreciate being here right now. Simon Frechette, I'm the CEO of CyberQ. We founded this company a couple of years ago for the sole purpose of automating a methodology that Phil and Susan created as officers in the Central Intelligence Agency for detecting deception. And thanks to Planet, we've been successful in that endeavor. I have worked about 17 years with Phil and Susan applying these methods in the private sector, primarily for institutional investors like hedge funds, private equity funds, also for large Fortune 200 organizations doing M&A, due diligence, and pre-hire screening. Susan, do you want to go ahead?
Sure. Again, thanks Planet and Ken for getting us in today and allowing us to talk on your podcast. I have a very long, several decades long relationship with the CIA. It's where I met Phil. He's actually the main architecture behind the detection of deception that we're going to talk about today. And I just joined him later on after he developed it and have been using it for many years. Like Simon and Phil, we use the methodology from a personal standpoint, but have been able to, again, through Planet's help, develop it into an AI product that everybody can use. You don't have to be an expert in deception to be able to use Q. Phil?
Excellent.
Super. Thanks, Susan and Simon. I'm a 25-year veteran of the CIA. Most of my focus during my career was in the world of polygraph, detecting deception, interviewing, and interrogation, and all of that wrapped into investigations, so to speak. Along the way, the organization, the agency encountered some very significant intelligence collection challenges, and much of that centered around the fact that our officers were getting snookered in terms of their ability to spot when someone was lying to them. So we were asked to put together a training program, and in that training program, we constructed a human model for detecting deception. And it's that human model that, as Simon, I think, alluded to, is the genesis, if you will, for years later automating the model. And I also just want to say we would never have been able to have done that without the help of Planet. Our specialty for the three of us is all in behavior. We're not tech people, but with their help, on the tech side and our contribution from the behavioral side. I think we've developed a tool that is, as you'll see in the demo, is very, very effective. Simon?
Excellent, excellent. So let's talk a little bit about the chat, a little bit more about how you got this started and why you got it started, right, Simon?
Sure. So actually, this journey started well over a decade ago when we were working for a company that Phil founded, and we were applying these techniques to transcripts of earnings conference calls on behalf of institutional investors. And we had done thousands of these for hedge funds. And a professor at Harvard Business School came along and was intrigued by what we had been doing and did a back testing study on our library of analysis and found that the conclusions we were drawing on these conference calls were predictive of stock price movement. In fact, if you traded on them, you would beat the market by over 30%. And so that was, and he said that it was the only thing that he had ever seen that without a certain amount of energy and effort, he couldn't reproduce this. So we thought at that time we needed to somehow scale this because there was just a handful of us who had experience applying it. And AI was something that was an available option at the time, but when we tested it, it did not have the underlying capabilities that we needed to automate this methodology accurately. So we really put that on the shelf for about 10 years until the last couple of years, with the genesis of the large language models, we determined that it did now have the underlying capabilities. And again, the reason we really wanted to automate this methodology, and we've been thinking about this for so long, is that it takes a long time to be able to apply these methods effectively. And it's also a very labor intensive process. So for every hour of content that we're analyzing, it takes us about 3 hours to analyze that. So it's very labor intensive. And we also, even though we do this every single day, and the methodology is designed to reduce the impact of our own biases, we can't completely eliminate them, especially if the situation is personal to us. So the AI gave us the prospect of being able to do this at scale very quickly and be able to eliminate the impact of human bias on the process itself. So once we discovered that we thought AI could now handle automating this methodology, we realized that we really didn't have the skills we needed to automate it because we're not tech people. So we started asking around and we were looking for an organization that could help us do two different things. One of those, it was quite a tall order, actually. We're looking for an organization that could both help us fine tune one of these large language models, build us an environment in the cloud where nothing could come in or go out because of the sensitivity of our clients' content that be going in and out of there. And also give us the capability for non-tech people, of being able to continuously improve this over time without necessarily having the assistance of Planet or the development partner all the time. So we heard about Planet, and because we're focused on the government as our primary market, the fact that Planet could deploy into the most secret cloud was of significant interest to us. So that's when we, as soon as we started working with Planet, everything from there is just a great story. So we'll get into that, once we get into the solution itself.
Excellent, Simon. So ultimately, since you guys aren't techies, right? You wanted to create this nice user interface, this very friendly interface that could be used across multiple industries because it was so easy to use, but still provide automation for that methodology that you guys are so good at, right? So, and then on top of that, obviously making sure that all the security on the back end and the front end is all there so that this is highly secure as well for the different industries to work in. All right, so
Great point.
let's move on. Miguel's here, and Miguel's going to talk just briefly, really briefly, a little bit about what this looked like, and a little bit about the data. So Miguel.
Yeah, thanks, Ken. So really quick, as a lot of people would think that this is not as complex as you would think. Essentially, behind the scenes, from a technical perspective, we're looking at basically four core resources. Yes, they're supporting network resources and some other things that really that are dealing with the API. Then the API, obviously, with the application, you'll see a front end and everything else. But this is what the question and answer pairs are actually sent to on that engine. So the Azure OpenAI service, of course, is there, but we have the files and the documents that are used to infer and pass that information, but those need to be searched and those need to be indexed and preferably, obviously, from a vector perspective. This allows for it so it's not so much just a keyword search, but also from a semantic search as well. So there are the Azure AI search is actually complemented by additional Azure AI services besides the Azure OpenAI service itself. Now, I want to, and really what happens at that point is that the user is then going to submit that question through the UI, and that will then pass directly to the OpenAI model. That will then be passed to Azure AI Search based on the inference and basically taking and tokenizing. It's very interesting because AI Search and OpenAI utilize a separation, if you will, of key terms. And those are in AI, we call them tokens. And in the search world, we actually call them chunks. They're not one-to-one mapping, but those things are obviously related into almost like words, but it's not truly not words. And quite frankly, initially, OpenAI was priced based on tokens. Now you can buy the compute power almost like a vCPU or virtual CPU, and that's really what the whole system is.
Okay, excellent. Yeah, let's move on and talk a little bit about why data is so important. I know both Miguel and Simon have some thoughts about why the data is so important, right?
Yes,
Data
preparing the data is arguably, I would actually say, is just as important, if not more important, than the actual resources themselves. I think Simon will get into probably a little bit. When the first time that we ran this and ran against the API with just the raw data that we had, I think we were at about 7%, Simon, if I remember correctly.
8%
accuracy.
Yeah.
We didn't change the data. We actually kind of reformatted it and made sure that, well, there's a couple things I should say. Most people look at a file, and again, we have the methodology that is obviously Phil and their proprietary information on how deceptive behavior is determined from a question and answer pair. That is placed into a document, whether that be a Word document, PDF document, or text. And by the way, from a search perspective, how that's actually chunked and separated out is critical. But if you look at a Word file, what you're looking at is the visual representation of that file. Behind the scenes, there are obviously a lot of special characters that specify headings and so forth. Those have impact when we're applying a search engine to it, especially AI search engine to it. Even though it may look like a heading and look like this, it may not be the same. That was critical. Eventually, what we needed to do, and what was kind of an eye-opener, was that we went back and reformatted the raw data within these files. We also allowed for it to be hit the same data by different what we call I filters or index filters. Whether that's a text file I filter is different than a PDF I filter, which is different than a Word doc or a docx I filter as well. that's one piece of it. The other piece, of course, that's going to be very critical is the, if you will, the training of the prompt. And I think when we first got into AI several years ago, even when I was doing all the presentations for Microsoft around the country for very critical clients, it was, and you still run across people who say, well, the prompt is everything. Yes, the prompt is important, but you don't have to be a prompt engineer. Why not use AI to help you create the proper prompts? In other words, have it say, so what would have been better for me to ask this if that was the case? And that's just an example. There's many other ways you can do that. And this applies to anything and everything from an AI perspective. In all the AI engines and all the AI models I work with, and I work with dozens over the period of a week or a couple weeks, not just the Microsoft ones or the OpenAI ones, but across all models, your prompt is going to be different. And quite frankly, even based on models, if you go from one model to another and use the exact same prompt, that prompt may not be the best for that model. So using AI to actually do that as well. So there's two things that really have nothing to do with the AI service or the AI model itself. One is making sure that the data is formatted correctly. If it's not good, if your data is bad, if it has mistakes in it, and you're using it for inference or for training, we didn't quote unquote true AI model training. It will actually cause failure in probably what you're looking for from a result perspective. And the other piece, of course, is the prompts. I don't know. We'll probably get into a little bit more detail exactly how that looks like here in a few minutes when we actually demo that as well. Other than that, I think that's really, I'm going to keep that kind of short and sweet so you can kind of get into this get into this. Thanks, Ken.
So in essence, you used AI to improve AI.
Yes.
Yeah, that's pretty cool.
And be careful. This is where we get into that edge scenario where people start going, well, wait a second, is AI going to get smart enough to actually train or improve itself? We're already at that point, guys. So.
All right, Simon. So the company and Planet created the solution called Q, right? So tell us about this actual solution now.
Thanks, Ken. So we approached this in two different phases. The first phase was to make sure that we could actually successfully train AI to detect deception. And so, like Miguel was saying, that involved, we're using a retrieval augmented generation approach, which is why we're not technically training. But as some people say, a good model doesn't require fine tuning. So the fine tuning that we had to use was improving the quality of the data and improving the prompts. And it turned out that the system itself, which we call Q, was our best assistant in that process. So the picture you see there on the right is we actually asked Q, we asked the foundational model, language model under Q. We described what Q is to the language model and said, generate an image of what Q looks like. And so this is the image that the language model produced. So this has become our understanding of what Q looks like. So we may refer to Q as he, although Susan seems to think that that might be a female, so she might call Q she. But like Miguel was saying, we started out with our initial data. We created two different data sets to train this model on how to detect deception. The first was a training manual. We were essentially thinking to ourselves, how would we train a human being? And we're going to take that same approach with the language model. So we created a training manual which outlines how to apply this methodology and all the different behaviors that you need to identify in this system. And then we had a large database of examples, validated examples of situations where we knew the outcome and the individual was either engaged in deception or they were telling the truth. And so when we initially fed in this system and used a very simple prompt and said, apply this methodology to this transcript, 8% was our initial accuracy. And so we had a long way to go. Our goal was to at least get 88% accuracy, which is what the polygraph is claimed to be able to achieve. And so we thought if we could get there, then we'd be successful. And so through thankfully, we had Q as part of this process, which is the underlying language model, to assist us in improving our data and the prompts. We ultimately had to come up with a very complex way of approaching this that was far more complex than what we had anticipated, which involved a multi-shot prompt and we actually had to separate out from a transcript each individual question and answer and hit it with a multi-shot prompt to be able to harness the language model the way we wanted it to and get the results we were looking for. So we started to use some of the cutting edge techniques for fine tuning, such as segmented analysis by breaking down the task into smaller parts and by basically ordering the sequence of events. So we were instructing it to apply the methodology in a particular sequence, which really enhanced the results. The other thing that was interesting is that the theory of AI in this situation is that AI has the capability of learning what deception looks like, and then you can have it learn and then go apply it and figure out if this is in fact deception. We found that that's largely the case in many instances, but we focused more on instructing it what deception looks like, not letting it determine what deception looks like, because in certain instances, the language model was creating incorrect rules. So we actually had to remove examples, every single example of one particular behavior, and only provide descriptions of what that behavior looks like in order for it to accurately identify that behavior. The language model itself we were able to communicate with the language model, give it examples, and say, why did you miss this particular behavior? How can I change the definition of this behavior so that you can more accurately identify it? And so we went through this co-evolution process with the AI itself to help to get its understanding for how we can help it learn more effectively. And we use that also with the prompt engineering. So it was definitely a critical piece of our ability to go from where we started, which was 8% accuracy, to ultimately 92% accuracy. So the system itself, the idea was to create something very simple that anyone can use. So the end user simply inputs a transcript and they get out the conclusions, which are either deceptive behavior indicated, no deceptive behavior indicated, or indicated follow-up needed, which is essentially inconclusive. And we get 92% accuracy in terms of Q's ability to differentiate between truthful and deceptive responses to individual questions, and a 4% inconclusive rate, which is a very low inconclusive rate relative to the polygraph in many government organizations. At the same time, we did not want the end user to have access to any of the proprietary prompt engineering or underlying definitions of behaviors and even behavior names. We had to re-engineer the names of the behaviors and the definitions themselves to perfect them to be compatible with AI. And so we had a very tall order the second time around with Planet, was to create a system now that we were able to accurately, successfully fine-tune this model. We needed a user interface that would hide and automate all of this stuff that's going on behind the scenes. We didn't want anyone to see what the prompts were. We didn't want them to see the analysis that was going on behind the conclusion. And we wanted them to be able to simply put in a transcript and get the conclusions back. So what Planet was able to do was, we weren't sure if that was even going to be possible, but not an issue at all for Planet. So what they did was they built something called middleware that did all of that stuff behind the scenes for us, and also enables us to control, to change, augment the data and the prompts so that we can improve the system over time. The beautiful thing also about the retrieval augmented generation approach that we're using is that it enables us to go on any of the new large language models instantly. So we don't have to fine tune a new model when it comes out. We just use our existing architecture and put it right on top of a new model, and we can test to see if it improved it or if it actually detracted from it. And interestingly, we found that you would think that with each new generation of models that it would actually improve. We've not had that experience. Actually, the first model we use is the model that we are still on after over a year. And although one of the newest models that has come out within the last week that we have access to, we're seeing some encouraging results, but we have not gone through the comprehensive testing process yet. Phil, Susan, what would you guys add?
Simon, I think you covered it very, very well. The one thing that I would maybe mention or explore a little bit more is the indicated follow-up needed. The fact that what's very, very unique and was never available in the polygraph is a solution to an inconclusive. It is once it's inconclusive, there's no path to resolution. What we discovered with Q, and Simon alluded to this earlier, we can query him and ask him, why are you having difficulty in analyzing this particular question and answer? And he often would come back with what we call an if this then that. He would say, if this sentence or this phrase means this, he's telling the truth. Conversely, if this phrase means that, then he is being deceptive. And what we realize is we can actually increase the accuracy rate from 92%. So it's really is a 92+% accuracy rate, because we can clear up the inconclusives, which heretofore was never really an option for the polygraph.
Yeah, good point.
I think you covered it very well, Simon.
Okay.
I don't really have anything to add.
All right, so I'm sure everybody wants to get to the demo, but before we get to the demo, so like just in summary, right? This highlights what our project basically focused on, and it truly was a collaboration between Planet and CyberQ. Obviously, significant advancements over the traditional way that this was done in the past, and then now it's open to even more industries, right? So like huge, especially in the financial industry, I think there's obviously you guys are seeing huge success, and so that's just kind of a wrap up. I don't know if you guys want to say anything else about the project wrap up before we go to the demo.
No, let's go to the
Okay,
demo.
let's do the demo. Okay,
Yeah.
I'm going to go ahead and release my desktop for you to take over now, Simon. Go ahead.
Okay. So what you're looking at is the user interface that Planet and we completed just weeks ago. So what we wanted to develop is a way for a customer to be able to look at the data that they've generated in two different ways. One is at a very high level, where we want to give them the capability of doing a triage. So for instance, if a customer has 200 suspects in a particular investigation that they're doing, and they want to be able to narrow down the list of suspects very quickly. If they were to put in all interviews of every single one of those suspects, they could actually sort the suspect interviews by the percent of questions to which the individual answered deceptively, so that they could start from the top and go after the most likely suspect first, be able to determine quickly if there's a potential conspiracy, also be able to rule out certain people where there's no deception indicated whatsoever. So that was at a high level what we wanted them to be able to do. Now I'm going to show you, I'm going to show you how quickly this thing operates. So I'm going to add a transcript of a collection of question and answers from different situations, many of which you may have heard of before. Now, all I'm uploading is a text file with the questions and answers. One of the things that we do is we intentionally eliminate the names of the interviewer and the respondent to eliminate any possibility that there could be AI bias associated with that name. Because at the end of the day, these models were trained on human language. Humans have biases. So there's a possibility that there could be an effect. We eliminated that possibility by eliminating the names. So what you're looking at is each question and answer while it's being analyzed. So here's an example right here of a question and answer from an exchange with the CEO of a bank called Silicon Valley Bank right before the company collapsed. And in fact, it's already done being analyzed by Q. So before we can even really get into the substance of the response, Q's already done its analysis. Something like this could take us, a half an hour to really go through and analyze. So what we're going to show you is not only the conclusion, so Q has determined that this is a deceptive response, but what we also do is provide a scrubbed high-level analysis along with it when we're doing demonstrations to show what's going on behind the scenes, what is behind the conclusion that Q has reached. So I'll give you an opportunity to read this question and answer, then we can go down and look at the analysis, what's behind the conclusion. So if I haven't mentioned it, this company collapsed very soon after this question and answer exchange with the CEO. So here's the analysis. So what we found in training law enforcement, investors, Big Four auditors, is that people have a very hard time detecting deception. And even if they have the skills, having the level of confidence to actually make a call, it can be very difficult. And what Q is designed to do is be diagnostic and make a call. The methodology itself enables Q to do that, but Q is going to determine with a high level of accuracy whether or not somebody is engaged in deception. And we consider deception a very wide spectrum, anywhere from having a significant lack of confidence in the information they're providing to deliberately providing false information. So there's a spectrum that includes things like omission of information. That's something that Q can detect as well. So by now, Q has analyzed all of these questions. Here's another example. Phil, do you want to talk about this one?
Which one is this, Simon? I'm having trouble with the screen here.
This is, have you ever delivered?
Yeah.
You see it? Okay.
Yeah, this is a question that was taken from a security interview, and there were concerns as to whether or not this individual had provided false intelligence information. And in fact, as you'll see from Q's analysis, he did. And actually, this turned out to be a major faux pas, or with respect to the agency's attempt to collect the information.
This is an example of an interview with a police officer named Drew Peterson. At this time, he had been accused of murdering 2 wives, and he's asked a direct question about whether or not, he engaged in a certain act of violence.
What a deflection in the answers. That's what
Absolutely.
I'm saying. Yeah.
And he was ultimately convicted of both murders. In fact, at the time this interview was conducted, his second wife was missing, and her name was Stacy, and they actually exhumed the body of his first wife, Kathleen, and did another autopsy and determined that what appeared initially as an accident was actually staged, and he murdered her. So now Q's done with everything. This is an example of a question asked to a UFC fighter about using steroids. Phil or Susan, do you want to discuss this example? I think this is Computer Associates.
Susan, do you want to do it, or I'd be happy to as well? Yeah, this is a case that involved a CEO of a company called Computer Associates. They were a darling of Wall Street at the time that this occurred. And unfortunately, some of their employees came forward to the New York Times and accused the company of cooking the books. Sanjay Kumar, who was the CEO, he went on TV to try to persuade everyone that they weren't cooking the books. And this is one of the key questions in the interview. As you'll see, Q thinks that doesn't think very highly of the answer. It was an interesting case because at the end, they as this interview was occurring on TV, the stock price was going up, it had dropped a bit, but based on what he was saying, he was clearly influencing the investor world that, hey, don't worry about this, it's not a big deal. Well, it turned out to be a huge deal. Sanjay was given the largest personal fine ever given by the SEC at that time of $880 million, I believe. And then he was sentenced to a prison for 12 years. So it was a very, very big deal. But it's interesting how easy people can be persuaded to believe something that just is patently, false.
One of the critical aspects of this methodology is the ability for for a human, the first thing we do when we're analyzing a response is determine, did the person answer the question? And that was one of the things that we needed to make sure that the language model could do. The early machine learning and natural language processing simply couldn't do that. But when we determined that these language models had that capability of understanding the question, the intent of the question, and whether or not the response answered that question completely, was very, very significant. And in fact, its capability has exceeded that of our own at this point, because we are able to give it, with the help of AI, instructions for how to make that determination that are very comprehensive and go well beyond what a human can do. And so we've seen examples where we thought the person was answering the question. Q says, no, they're not. And then we would challenge Q. We say, and this is through the back end where we can have a direct conversation with the language model. And we would say, and Q will either dig in when it has the basis to be confident, or on some instances, it will actually acknowledge that it may have looked at something, the wrong way, and we can retrain it after that, after we figure out, why it looked at it the wrong way. But in the instance where it can dig in and confidently defend itself, we learn a lot. And so there have been situations where we realize, in fact, wow, the person didn't answer the question, and it can explain to us very very effectively why the person didn't answer the question. And so that's one of the behaviors we've been really impressed with, its ability to identify. And it's the first thing, that we do when we're looking at a response. Phil, do you want to talk about this one as well?
Sure. This comes from a case that Susan and I worked on for years. It is a child abduction case out in Kansas City. It's referred to as the Baby Lisa case. Her parents woke up in the middle of the night and alleged to the police that the child, was abducted, and at the time, the law enforcement immediately focused in on the parents, and because there was no evidence of of wrongdoing. And in reality, what happened is that the parents, it's highly likely the parents didn't do it. And Jeremy, who's the father of the child, this was validated as truthful, years ago, because he was working that night as an electrician in the building of a Starbucks, and he was on closed circuit TV all evening. They had closed circuit TVs in there on the work site, and his colleagues validated that he was there the whole time. So he was not involved in any of the abduction, so to speak.
And the way the methodology works, and the way that Q works, is that Q is looking for signs of deception in response to a stimulus, and in the absence of clusters of deceptive behavior or deceptive symptoms in response to a single question or stimulus, and Q is going to make the determination that there's no deception. So it's like a medical model for diagnosis.
And it's important to know that you didn't train Q at all on truthful behavior, only deceptive behavior, right?
Correct.
That's amazing. That's cool.
Part of the methodology that I mean, this is one particular feature that I think was a big breakthrough, right? When you figured out that part. Do you want to talk about that element of it, Phil?
Sure. For years, people were trained to say, here's a list of behaviors that are truthful, and here's a list of behaviors that are deceptive. And on one level, it sounds logical, but in reality, the problem that they didn't address is that truthful people do exhibit those kinds of behaviors, but so do deceptive people. Typically, they will often mimic or mirror what is traditionally seen as truthful behavior, and that really muddles the water. So if you eliminate what looks, truthful and just, go on the formula that Simon just described, it works very well. In essence, it's based on the medical model. If you go in for your annual physical, in reality, they're not going to, the physician is not going to base much of his assessment or her assessment on how well good the person looks. It's going to be whether or not they have symptoms that are concerning.
Interesting.
And that's exactly what we modeled this after.
This is an example of a company called Wirecard, and this is it was a German payment processing company, and this is an exchange that took place in an article. So all we had was just the text, which is all we needed, and this exchange occurred 5 years before the company completely imploded. It was total fraud, and the value of the company at the time that it imploded exceeded that of Ford Motor Company. The collapse of the company like rocked the German financial system, and it was a really significant black eye for Ernst & Young, their auditor. And had they had this capability 5 years earlier, they could have seen that this was an alarming response. And Q has absolutely no hesitation concluding there's deception here.
All right. Well, we're getting close to time here. I want to open it up to questions. If anybody has any questions, please either raise your hand. We'll take off. You can come off mute, or just you can ask away in the chat window. There was a question. Says, in response with several sets of Q&A, is context of other answers taken into account among the set of questions? Contradictory statements, for example.
Simon, you want to take that one, or?
Sure. If I understand the question correctly, and please let me know if I'm not, are you asking if other responses to other questions are taken into consideration? Is that the question? In the analysis of an individual response? Yeah. So
correct. Yeah.
This system and the methodology itself, with every new question, you give the individual a clean slate, and so you're assessing the response to an individual question. And the beauty of that is that when you're going through an interview, you can see where's the deception, what issue is the deception on. And so if you're looking at a company to acquire, or you're looking at a company to invest in, or an individual to hire, you can see, is this a lethal issue? Is the person hiding a criminal record or criminal activity, or maybe they're embellishing their resume a little bit. Two very different issues, but you can see it's very surgical in the sense you can see where the deception is. In order to maximize the effectiveness of this system, we needed to take every single question answer and analyze them in isolation and with a multi-shot prompt to segment the analysis into smaller chunks to really harness the power of the system. So We do not look at previous questions and answers. And there's also other reasons for that. Just like a human being, when we're doing an interview, if we see deception in, let's say, the response to the first question, we're more likely to see it in subsequent responses. And vice versa, if we don't see deception in our first few questions, we are less likely to find it in subsequent questions, even if it's there. So we develop a bias during the course of the interview. We found in our testing that AI has a similar bias. It takes similar shortcuts. If it sees deception earlier, it's more likely to find it subsequently, and vice versa. So this was another reason we really needed to perform the analysis of each Q&A in isolation. Now, the thing about inconsistencies is those are certainly something we look for, but the good thing is that humans are very capable of performing that assessment themselves. They can look at facts and see, are these facts consistent with each other? So that's one thing that we don't, the investigators are capable of doing on their own is basically comparing statements, doing statement analysis and determining if the statements are consistent or not. So that's not something that we feel the need to incorporate into the system at this point. Phil, do you want to add or anything?
Very good answer. The only thing I would add is the human mind relies heavily on patterns, and most of their analysis almost always incorporates those patterns. Q doesn't need to rely on that based on what Simon described.
We had a comment in the chat that says this is one of the most interesting demos I've ever seen. They could sit here all day. That's exactly how I felt when I started working with these guys, and they started sharing some examples. I'm going, yeah, that makes sense. Yeah. So thank you for your feedback there. We had a question that came in earlier about quantization. Miguel, do you think you could answer that in like 10 seconds, 15 seconds? Because we're starting
10, 15 seconds? Yeah, sure.
Yeah,
I'll give it a shot. So someone actually asked about quantization, what it is and how it's kind of applied in AI. Really quick, from an AI perspective, quantization is basically so behind the scenes, AI is obviously, think of it as like a neural network, and everything is actually represented by vectors and in very, very high scale. Think 32-bit integers, etc. Quantization is actually when we take and scale those down. What that does is provides the model size drops. It allows for faster computation in AI, and it also means I'm also going to consume less power on that model. The two things that you'll typically see when you're dealing with quantization is two ways it's actually done is either post-training, and that means that we're going to quantize the after it's been trained, and then we also have, and that's typically referred to as a PTQ, and then we also have QAT, which is when we're actually doing the quantization during or quantization aware training. So that's what we're actually doing the model to actually be trained. The significant benefit, of course, faster, smaller as far as a footprint, and also less power, therefore less compute. So I hope that answers the question, whoever sent that in.
Thank you for consolidating that quickly. I appreciate it. If you want to follow up, please reach out to us. We'll get you some more information or set up a one-on-one with you. All right. So, it sounds like from the poll that we saw earlier, 70% of people are still investigating AI services in Azure. So we want to make sure that you're aware that, here at Planet with the You Already Own It program, we have lots of workshops. And this workshop right here is all about building use cases and understanding priorities and figuring out business solutions to those use cases. So we're offering a 2-hour. Oh, sorry. Thank you for saying something.
Oh yeah, let me stop.
I forgot to take back ownership.
There you go.
My apologies. So yeah, so this is all about one of the workshops. It's all about developing use cases, having an envisioning session with one of our organizational change management folks to talk about your priorities and find business solutions to them using Azure AI services. If you're interested in this, please reach out to us. Again, these are no sales. We want to have conversations about building these solutions and helping you get started on the way. The second one we have is if you have some use cases and now you're ready to take the next step and you want to know more about Azure OpenAI or AI services, this is a fundamentals class about understanding the building blocks for AI models and then exploring AI applications and then seeing some demos and things like that. And I think, Miguel, you do some of these as part of your work here at Planet.
Yes.
And then to support you all, as I always do, I put some links in here about some of the articles about CyberQ, as well as what Azure AI Services is all about. There's lots of different capabilities in Azure AI Services. I just met with a customer in the last month talking about the video indexer, which is pretty cool from an Azure AI service. It's about like uploading mass quantities of video and then doing indexing and searching on that for especially in police work, right? You know, finding the logo for Toyota in a 2-hour long surveillance thing, or a backpack that's red or something like that. Some really cool capabilities here in Azure AI Services. I implore you to look at these services and start thinking about use cases in your own environments. Again, this is all part of the You Already Own It program. If you're not a member yet and you want to get part of this, we want to make sure we onboard you so you're aware of all the workshops that we have available, which are on this screen right here. They range from anywhere from an hour to 2.5 hours. And they're yours for the taking. Again, they're in a non-sales environment. You know, we're just making sure that it's our investment with you all as customers. We want to make sure that you're briefed and making sure that you're getting the the return on investment in your Microsoft licensing and understand everything that's included in the Microsoft ecosystem in case you're getting ready to deploy something. So please reach out to us. Our next office hours is going to be on April 24th at 1 o'clock. I believe it's going to be on identity and securing identity, depending on which kind of licensing you have. We're going to talk about, the E3, G3, the E5, G3, G5s, and then also the new Entra suite of capabilities for protecting identities in Microsoft 365. We would love for you to fill out this last survey here just to see how we did today. So if you get a second, please do that. And then finally, we want to thank you all for joining our cloud office hours this afternoon. We hope you found the insights on this helpful, and you're starting to think about your own use cases here in Azure AI. And if you're ready to take the next step and get started, make sure you reach out to us and take advantage of one of those free workshops. We're here to help. As always, thank you very much, and we will, sorry about that. Thank you very much, and we'll see you on April 24th at our next event. Thank you again, CyberQ, for joining us today. We really appreciate you taking the time and explaining your solution to us. I think you got a lot of people scratching their heads thinking about what they can do next. I appreciate it. Have a great day.
Thank you. Thanks, guys.